4 warga Thailand yang disyaki terlibat dalam kes penemuan
Keselamatan lain, beliau menjelaskan laporan
termasuk
dan terus dipertingkatkan dari
PDRM.
fahamkan bahawa hakim
Radar systems can use monostatic or bistatic configurations. Forward scatter radar detects targets by analyzing signal changes when they pass between a transmitter and receiver. This project uses passive forward scatter radar with LTE signals to detect humans without an active transmitter. The objectives of this project are, first, to analyze a passive forward scatter radar, or PFSR, for human detection using 4 different frequencies from 4G and 5G networks. Second, to evaluate human Doppler signatures at 3 different locations. Finally, to classify the human Doppler signatures obtained from the PFSR signals. The experiment was conducted at 3 different locations. The first location is Kampong Bukit Bangkong, which is a semi-urban area with a transmitter and receiver distance of about 127 meters. The second location is Taman Botani Shah Lam, which is a forest area with a distance of about 114 meters. The third location is Taman Tasik Cyberjaya, an urban area with a longer distance of about 319 meters. These different environments help us compare the radar performance under different conditions. The research process starts with data collection. Next, the collected data is selected and analyzed using power spectral density, or PSD. Then, principal component analysis, or PCA, is used to extract important features. Finally, a confusion matrix is used to evaluate the classification performance. 4 frequencies were selected for this research: 1.8 GHz, 2.1 GHz, 2.6 GHz, and 3.5 GHz, as mapped from the MCMC spectrum allocations. The 1.8, 2.1, and 2.6 GHz frequencies represent our 4G LTE communication signals, while the 3.5 GHz frequency represents our 5G signal. Together, these 4G and 5G signals serve as the ambient radar sources for target detection. 3 participants with different body sizes took part in the experiment. Their width, height, and body dimensions were measured. This is the result of time domain at Kampong Bukit Bangkong with 4 different frequency. The 3.5 GHz frequency achieved the best performance, enabling accurate time domain analysis in which larger human dimensions produced longer signal durations and higher received voltages. This is the result of power spectrum density at Kampong Bukit Bangkong with 4 different frequency. PSD varies across different frequencies and locations, providing valuable information to distinguish between larger and smaller human dimensions. This is the result of principal component analysis at Kampong Bukit Bangkong with 4 different frequency. The clearest feature separation with minimal overlap improves classification accuracy, and an accuracy of 80% or above is considered good. The time domain shows that larger humans produce longer signal durations and higher voltage. The PSD shows wider spectra and higher power, while PCA achieved up to 99.75% classification accuracy. Overall, the proposed passive forward scatter radar can accurately distinguish different human body sizes. The confusion matrix is used to measure the classification accuracy. The results show that different locations have different, best performing frequencies. This means the environment affects radar performance, and each frequency has its own advantage depending on the location. This slide shows the signal strength analysis using RSRP and RSRQ values. These measurements help evaluate the quality of the communication signals used by the passive radar system.
100 yes! Detects anything without being seen. Many things!
In conclusion, this research shows that passive forward scatter radar can successfully detect and classify human movement using existing 4G and 5G communication signals. Different locations produce different Doppler signatures, while PCA provides accurate classification of the collected data. Overall, the study demonstrates that LTE and 5G base stations can be used as signal sources for passive radar applications.